people just want to walk in, they can. No big deal. So, hi. How's it going? Oops. My name's Colin Couchet, and I work in blockchain, and I'm going to give you a introduction to blockchain, smart contracts, and tokens. So, there's a lot of content here to cover, so I'm going to try and go through it as clearly as I can. But since there's so few people in the room, I won't be too upset if you guys decide that you need to ask me a quick question, but for the most part, try and hold them to the end, because there's a whole lot of stuff that I'm not sure how much I'll ramble on about and how far I'll get through it, but we'll see, because this is a deep topic. But just tell you a little bit more about myself, my credentials, where I come from. So I've been a full stack developer for this is about 1999, I guess, is before the word full stack was even commonly used, and I've worked in startups and whatnot. I got into some perceptual hashing, tried to do a startup with that, and then cryptocurrency has always been something that's kind of been on the back of my mind, is this is going to be really cool. So when I had a transition period, I looked specifically for a blockchain position. I've been working in blockchain, dealing with Ethereum ever since. I work for a company called Animal Ventures. We're not promoting a product, just letting you know. We work with Fortune 100 companies to implement blockchain proof of concepts onto their network, and that's a huge hot topic right now, because what I'm noticing is not a lot of people know a great deal about blockchain and blockchain technology. They know kind of the idea of what stuff it can do, but they don't really have a good understanding of why, how, what impact it'll have in society in general. And I believe that blockchain technology will be probably one of the more impactful technologies that you have seen since dawn of early internet. It's kind of going to change the way that we operate on a very fundamental level from all aspects of society. So I'm really excited to be in this particular field, and I'm really happy I get to share with you guys. So just out of curiosity, how many of you here have owned a piece of cryptocurrency, a Bitcoin, an Ethereum, or anything, some sort of altcoin? You? So we got 3 people. So most of you, do you know anything about blockchain? Who here's read up on it or has some sort of cursory knowledge on it? Okay, about half. So you know, I'm not going to get into too many of the technical details. Part of the reason for that is that it's a lot to cover. It's pretty much its own presentation in and of itself. So if you're really technical focused, we could talk afterwards, and that would be fantastic. I love to talk shop. But the gear of this is definitely going to be more towards educating folks in the room on what blockchain is, what cryptocurrencies kind of are, some of the higher level aspects, and as well as the societal impact of the technology itself. So, what is blockchain? That is the question I'm asked almost every day these days. You know, I keep hearing about blockchain. What is blockchain? What does this thing do? Why is everybody chomping at the bit to get blockchain onto our, integrated into our systems? And for the most part, it's actually a pretty straightforward answer. It's a database, a ledger of transactions. So, like when you make a transaction between, yourself and the bank, it's a ledger of transactions. It's a public, decentralized, peer-to-peer, time-stamped, non-reputable ledger of transactions. Now, I think the last one is the most important one, in that this particular non-reputable basically means that you know that when someone signs a transaction and transfers you money, that money's guaranteed to be there, and you're guaranteed to get it as long as they have it. Why is that important? Because of the decentralized portion. So decentralization is a concept that I think most people kind of misunderstand on a fundamental level, because they think, oh, it's distributed, and they think that distributed and decentralized are the same thing. But really what this means is that everybody has a copy of the data. Everybody has the full history of what's going on this transactions. Imagine if your bank gave you their database. That is what you're looking at with a blockchain, is basically you have the ability to download and peer-to-peer connect and write to a database that nobody can really refute the validity of. That's the big change here. That's a really, really compelling change when you think about it, because we have so many problems in data dealing with validity, just trying to figure out if the data is correct, if you timed it right, or anything like that. Blockchain covers all of that. And so it's a pretty awesome in that it enables some significant changes to the way that we design software going forward, as well as design larger systems, because it enables trustless systems. So you don't need a central authority. You don't need Uber to hold your money for you until the ride is over. You know that you can actually write something that'll do it automatically. You're automating that business process. It doesn't need trust. There's no need to worry. It's completely trustless. You don't need to rely on the concept of trust at all, because it's inherent to the system pretty much. There's immutable sharing, which means that you can actually create historical records and be certain that they're correct. So let's say a political candidate wants to record their entire history of where they've been, what they're doing, that kind of thing, and you don't want those records to ever be tampered with going forward. You know, the victor rewrites the history books or something like that. Imagine if everybody just started writing their journals or something in some sort of immutable database that they share with everybody. And people who subscribe to that can verify the validity of that particular data. That changes the way we look at history. Not just that, but I mean, it really does impact how we handle banking, finance, all that stuff. Because if we know that that data is not changing, we can guarantee that that it is correct. You know, and that's a big thing. We don't want somebody going back and then rewriting a little number here, and then suddenly, you know, they have $1 million. You know, that's important. They can't change it once the data's in there. And then transparency is the other big one. If somebody, you know, wants to make a change, they can't. That's great, but the fact that you can see every bit of history means you can validate the entire record yourself and go, where did this money come from? All the way down to the root source, all the way down to when that money was produced in the blockchain, which is something I'll get into in a moment. So blockchain enables a lot of fundamental changes in the way that we conduct business, in the way that we conduct software development. It impacts so many weird vectors that you wouldn't even have really thought could use it. As you get into the field and you start exploring, you're like, wow, this is an application for blockchain I didn't think of. It's very impressive. So most people know blockchain from the idea of Bitcoin, and we'll get into that, but, well, I'll just do it now. The reason we haven't done this before, the reason this is new, the reason that this is all only happening since about 2008 is because of a white paper posted by an anonymous person. I call him anonymous because we don't know who this person is. It was posted on crypto forums and just spread like wildfire. And this person's name was Satoshi Nakamoto. And this is the pseudonym that they published under, but we still don't know who that person is. And there's no person who exists who named Satoshi Nakamoto in the crypto field who even has any done that. So it could have been multiple people coming together to produce this white paper, but either way, we don't know who it is. It was released by an anonymous person. It's almost like something straight out of an anime. Like they just this was like they were sitting on it and they're like, oh, there's so many implications, and then they just threw it out there to let the world do it because it's strange. I'm not really quite sure why they would post under a pseudonym, but they did. And Satoshi Nakamoto proposed the concept of a blockchain, and the blockchain is something that solves the double spend problem. And the double spend problem is basically brought down to this. If you have, you have 10 coin and you have 100 coin, and he gives you 10, and you have 50 coin, and he gives you 10 coin, he gives you, you give him 10 coin, and you give him 10 coin at the same time, exactly the same time, how do you make sure that you don't both have the same 10 coin that he does? Doesn't even matter how much you guys had. But the point is, like, how do you make sure that he hasn't spent twice? And everybody in this room should probably be familiar with this concept. It's duping. It's video game duping. It's the same concept. Somebody drops an item on the floor in Diablo, picks it up too quick, suddenly they have 2 items. You know? It's the same concept. It's duping of asset. But this is even more difficult because an asset, as far as currency goes and account balances, is nothing more than a number. So it's like, you have 10, you know, you have 100, you have 50. That's your account balance. These are just integers, they're just numbers. So it's more than just a particular item with a particular set of stats. It's actually like that number is just associated with your person. And so the double spend problem was a big issue that prevented electronic currencies from taking over. I mean, they've obviously theorized about that for ages, but it never really happened. It never materialized. And well, not until Satoshi Nakamoto posted the Bitcoin white paper. And that's what we started implementing back in the day, and then people started using it, and then it all started showing that it actually had value without actually needing to have a government backing it. So people were exchanging goods and items for Bitcoin without any government intervention whatsoever. The government didn't say, hey, we're printing a bunch of Bitcoin. It just printed itself, and it did so at a predictable rate on a predictable algorithm that everybody knew about, and everybody could watch the whole transaction history, posted it to anonymous addresses, and people received these Bitcoins and used them to exchange goods and services without any backing of any government authority, which is huge. So that's one of the reasons why Bitcoin is such blockchain in general, such a fundamentally world-changing technology. So we have always had trust in society and institutions. We trust the Fed to print our money. We trust the fiat, the US dollar, to back anything that we're giving. Like, you know, hey, this dollar's real because it has the US dollar serial code on it. You can hold it up to the light, yada, yada, yada. And you see the little metal strip in there. Everything's there to create trust. When you might take that brown marker and you mark it on a $100 bill, that's so you could trust that the $100 bill is backed by the federal government and it's not double spent or printed falsely. Banks. We trust our banks on a daily basis. Should we? But we do. And so trust is kind of one of those inherent things that almost every major business in the world has some level of authority to them, some level of trust that they need to operate. Uber is an example. Airbnb is an example. You trust that they're going to do their job, and their job is to protect your interests. And the idea is to set up a structure so it's incentivized so that they're betraying too many customers' trust loses them customers. But what happens if their database gets hacked? What happens if, you know, these things happen all the time. What if they betray your trust and run off with the money? These happen in so many ways. Not saying these particular companies do it, but, you know, this is not an unknown thing. So that's why a centralized system like Airbnb, PayPal, you know, Uber, your bank, these are centralized systems. The Fed, Federal Reserve, decentralized economies are way more interesting to me because they prevent the need for those, but still allow the basic fundamental operations which these services offer. So I'll get into that a little more in a second, but the idea is that if everybody owns a copy and everybody's owning their own copy of the entire ledger of the bank, who needs the bank? So the obvious first use case that blockchain provides is the idea of a crypto asset. And everybody's mostly familiar with Bitcoin at this point. I feel as though most people have at least heard the term. They're like, I don't know what it is, but I've heard of it on the news. And crypto assets are, virtual currencies are basically, I call it a virtual currency to kind of appeal to this crowd, but they're really cryptocurrencies. And I'm doing that for a reason because I'm going to get to a point at the very end. But virtual currencies are basically just any currency which, well, y'all know, in-game gold. You know, if you try and make a purchase for something in the game has a gold system. You purchase with that gold. And some of the early ones, the early one was Bitcoin. The one I primarily work in is called Ethereum, and that one's particularly interesting to me. And then on top of the Ethereum network is tokens, which is a different kind of virtual currency. And I'll get into that a little bit, but basically it enables all different kinds of virtual currency, which all operate in their own unique way, all because they run on something known as a blockchain. So there's also virtual assets that you can actually use and manage with a blockchain as well. I'm going to liken this to maybe finding a particular item in a game, but there's also like collectible cards that you can hold in a collectible card game. so that you know that somebody isn't like duplicating your collectible cards, and you can sell them out. You give them a unique serialization, and then they can actually know that that particular card is valid. And then virtual marketplaces. So Diablo 3, for instance, had a real market auction house, which is well, we'll leave that out, but it wasn't the greatest thing in the world. Long story short is that virtual marketplaces can become much more reliable, and the exchange of value through them will be much more measurable, dependable. You can actually do some sort of market research. You can actually make a business around virtual marketplaces. So another one that I'm going to get into is the concept of provenance tracking. The provenance is basically how something is exchanged from one end of the, let's just call it a supply chain, to the other. So if somebody owns something and you want to know, how do I transfer this ownership to somebody else, and who owned it before, and is this ownership valid? A blockchain is an ideal exchange for that. It's literally the same kind of use case, but this time let's talk about like real world goods. So if you have a painting with a QR code embedded in the frame or something like that, you could actually say, or in some manner, you can actually associate that with an address and follow it all the way back to the original owner. If it doesn't look like the original owner actually handed it all off, then you know that QR code isn't correct. You know that the person who produced this item claims, the person that is selling this, who claims an original owner produced this item. You can verify that that person actually produced the item because they put it in a blockchain, in a mutable database, which makes sure that they know that all the way back to the beginning, that the owner produced this item. We could track that the owner had the item, and we could see all the people who transferred that item all the way through down to the end. So that works on, and that's just one use case and one type of provenance. There's a whole different way of that's a big category actually, especially in business these days. So, and then the idea of immutable storage, I kind of gone over a little bit more, a little bit before, but there's other applications of that. So it's not just historical records. You also have sharing your blog post revision history. So people can't delete a tweet. Like, let's say you created an immutable tweeting system. That's totally possible with blockchain. So you can't get frustrated that somebody's deleting these tweets, happens all the time. Historical records, I already went over before. Identity management's a big one too. So since it's immutable storage, and you can kind of verify the owner of a particular, let's just call it a wallet in the system, that wallet could be functioning as somebody's identity. And so imagine your passport held in a blockchain. And that blockchain, because it's valid, you can unlock your passport when you walk up to the airport terminal, unlock it with your secret code, maybe even a fingerprint or some biometric, some bio ID, maybe your DNA, who knows. And then that unlocks your passport automatically, so you don't have to walk around with this thing. You could never lose your passport because everybody has it, but nobody has it. Because until you unlock it and decrypt it from the database, it's just hanging out in the ether, let's just call it. Right. So, what is a block, and why do we call this blockchain? Well, blocks are a section of blockchain. So I talk about transactions a whole lot, and I talk about them in a way where it just sounds like transactions are going back and forth constantly, but that's not how a blockchain validates things. It validates things in chunks, and those chunks are called blocks. And a block is basically a chunk that is verified, and the way that verification happens is that a group of miners, nodes called miners, go out and they try and solve a really hard math problem. I could go into more detail. It's really, like, if you know hashing, you'll figure it out exactly. I'll just say this really quickly. If you know anything about hashing, MD5, SHA-256, whatever, if you were looking for a hash that had like 6 zeros in front of it, that would be how you sign a block. And everybody's mining, looking for a particular solution to this, to sign this block and finalize it, put it on the blockchain. And they're constantly searching for random numbers, because if you were to try and do that with like an actual like deterministic, like you go in and solve it kind of way, it would take you more time than it would take for the block to produce by far. So by hundreds, if not thousands of years. So with the current computing power we have. So you want to guess until you find one. And so people are dumping a ton of electricity on their graphics cards, on their processors, on ASICs, which are specific specific computing machines built just to solve this one problem. They're dumping all this electricity into solving the problem. And if they happen to solve it, if they happen to find one, they get awarded coin. And this is what's known as proof of work. And the reason so once they solve the problem, it adds the block to the blockchain. They get awarded coin, and then another problem is generated. And it just keeps going and going and going. And the transactions are part of the block. So actually, you need the transaction history of the unsigned block in order to get the next block, that block signed, and then the next block produced would have the new transactions that occurred in the period of time between that block being signed and the next one being, open and ready to go. So why would somebody produce blocks? Well, if you got 6 Bitcoin, which is currently approaching $5,000 per Bitcoin, and you accidentally stumbled upon the right number to sign a Bitcoin, and it takes let's just say every 10 minutes a Bitcoin's produced, a block is produced, and when you sign that block, you get 6 Bitcoin because you found it. That's good incentive, especially in countries like China, where it's a lot cheaper to run your electricity, and you can produce large farms of this stuff much easier than, say, in the United States, where our electric costs are a lot higher. Right now, to power the Bitcoin blockchain, I'm hearing that it takes all of the electricity, all the electricity for, I want to say, is it 1 block or 1 day? The country is Cyprus. All their electricity, now that I can't remember that, I guess that anecdote's not as great, but it takes all the electricity of Cyprus to produce, I guess I say, one block or 1 day's worth of blockchain. So it's actually a lot of electricity dumped into producing just this blockchain. It could power a whole country pretty well. So that's very inefficient. But that is how proof of work works. You solve the math problem, you get a coin, or several coins. But I don't work in Bitcoin, and I'm kind of looking forward to Ethereum. I work in Ethereum. I'm kind of looking forward to Ethereum ditching the proof of work algorithm. But I do work in a currency called Ethereum, which is currently using proof of work, but they're gonna switch it over to proof of stake. I'll talk about that in a minute. But Ethereum's really interesting for another reason. So imagine you can store code, programs on the blockchain in the form of opcodes. So it's like really byte code. So it's really compact code. Basically, you compile a program and stick it on the blockchain. Imagine that you can verify that you can have other people interact with your program, and exchange of value can happen as a result of that program that exists on the blockchain. And you publish that program completely open. That's what Ethereum does. Ethereum has something known as the smart contracts. And these smart contracts run on something known as the EVM, which is the Ethereum Virtual Machine. And what that allows is people to create something called dApps. And they are decentralized applications, which means that applications that actually really run in your web browser using something called MetaMask. You could use Parity. There's a lot of different browser extensions to actually do that, but hopefully in the future it'll be native. The EVM and smart contracts enable you to actually, in a language called Solidity, which is a JavaScript-like language, is actually built specifically for this purpose, create smart contracts and build dApps. And those dApps can do anything from having a very secure. So how many people have had like a poll on their site get like on a website get really torn up by like a bunch of trolls or something? Like, hey, could you imagine you had an identity and only people with a particular identity could vote? Like, you know what I mean? Like that, like you can't duplicate those votes because that identity. So that takes care of those online polls. If everybody had an identity associated with this particular thing, yeah, exactly. Well, I mean, it really depends on the system. So you can in theory construct a system which requires somebody to have a verified account, and then only verified accounts could vote.
Well, how does it get verified?
you'll have to design a system that does that. But the point is you can, and that's the important thing. So like imagine with the scenario where you have your passport, if somebody could sign things with their passport on the blockchain and basically like, I'm not going to give you my passport, but I'm going to sign it with my passport, then suddenly you're able to create a verified identity, and they could trace that back to who you actually are in some manner or form. Yeah. So there's a lot of ways you can automate these processes, which are extraordinarily manual right now, which is what's really interesting. But one other cool thing about Ethereum, and you might be hearing some of this going on these days, is this ICO. It's called Initial Coin Offering Spree, and a lot of that's because Ethereum has the ability to create tokens. And tokens are, they're kind of a coin on their own, but they're also kind of not a coin. And the reason I say kind of not a coin, it's up for some debate, but I feel as though they're not their own cryptocurrency. They are built using a smart contract on the Ethereum network, using a particular smart contract called an ERC20 contract, which is basically an implementation of basically an interface to interact with this contract. You can actually create your own tokens on the network, and those tokens can be used for your decentralized application and only your decentralized application, creating sub-economies within the blockchain. So Ethereum has its own coin called the Ether, but you don't want to exchange the Ether because you feel as though your coin has a different value proposition than the root Ether. So what you want to do is instead create a token which enables you to users to interact with your decentralized application in your economy on top of the Ethereum blockchain. So that's interesting for things like Golem, which I referenced earlier, which is a token which is used to pay for general compute resources, meaning that if you want to farm out your computer, kind of like SETI at home, to do complex calculations such as, rendering farms. Imagine a decentralized rendering farm that exists everywhere and nowhere at the same time. And you can just broadcast your model to it, and it will render and come back to you. That's what Golem is aiming to do, and that's a project still kind of in alpha mode. And you can actually power that with the Golem token, which runs on the Ethereum network. There's a myriad of other tokens or prediction markets like the Augur market, which has a rep token. All these businesses are throwing up tokens right now, but the main thing to get out of this is that these tokens are not the same thing as Ethereum. They are sub-currency. They are. So the analogy I use is that you really like skee-ball, so you want to play a game of skee-ball. Chuck E. Cheese you don't want your Chuck E. Cheese value to fluctuate per game with the US dollar, so Chuck E. Cheese has this thing where you could buy tokens inside of Chuck E. Cheese, and those tokens are valid as long as you're inside Chuck E. Cheese. But you step outside Chuck E. Cheese, you can't pay for your soda with a Chuck E. Cheese token, you know what I mean? So it's the same kind of idea. But you can exchange those tokens around as well, and you can, in the same way you would any other currency, and you can convert them to other currencies that also exist on this blockchain, and you can just be like, hey, you're on a different blockchain network, I have this token, you want this token, I want your token. Even though we're on a different blockchain network, we're going to work together in person to kind of like exchange them. Hopefully that could be more automated in the future. So this is all great, but kind of what makes a blockchain? How is this built? What does it consist of? Is a pretty it's actually pretty straightforward. I think I've explained a lot of it in passing almost already, but you need some sort of membership system. So you need somebody to be able to kind of like have a wallet, an identity, and a way of saying that this is my account, like a bank account number. You can have multiple bank account numbers and still be one person, but you need at least a number in order to do any transactions. So that's pretty much what the main part is. You need some identity management system, some sort of way of identifying who owns what, and that goes from the node all the way up to just regular users who just have a wallet ID that they transfer money around on, or anything around on. It doesn't have to be money, just data. So then you need transactions, which are, as I described before, things that happen on the blockchain. So we're going to generalize the concept of a transaction a little bit more. So a transaction is not just the exchange of value. It could also be just the exchange of information as value. So you don't have to necessarily be exchanging cryptocurrency to file a transaction. You could publish data, in which case there's a cost to publish the data on the blockchain, and that would be paid for in transaction fees. The larger the data, the more transaction fees you pay. Obviously, since everybody has a copy of this database, we don't want people publishing huge swaths of data onto the chain, and doing so should be costly if they do. They should be willing to pay for it. And when they pay for it, those transaction fees go towards the miners. In Ethereum, for instance, they go towards the miners. So if anybody who's mining these transactions actually gets a award for the transactions that they help process. So everybody's getting paid here. And the ledger is the history of the transaction. It is literally like everybody's account balance at the end of the day. How things exchanged, how things went around, and who has what. And then smart contracts are another thing that's kind of optional, but I think a lot of people are really trying to get them in their blockchains because Ethereum's being so successful. Smart contracts are a method for publishing logic onto the blockchain that can execute automatically as terms resolve. And so that's pretty epic right there. That allows for a lot of automated processes you wouldn't believe. The last part is a consensus network. So if anybody here is familiar with, well, who here? I would be very remiss if anybody here was not at least somewhat familiar with BitTorrent. So BitTorrent, of course, the files are chunked up, they're spread around, and everybody has a peer-to-peer connection, and they all just kind of like share this file, and that file allows them to download the real file that they want. So you get the torrent file, and then you actually download the real thing. This is similar in the fact that it is a blockchain. You listen for the blockchain over the network, and when you see packets arrive, you add them to your blockchain. You continually update your blockchain, kind of like a torrent that always grows. And that's part of the consensus network. Now, I call it a consensus network instead of just like a peer-to-peer network because you actually have to have everybody agree. And if your blockchain gets out of sync with everybody else, you either have to get it back into sync, which automatically happens when with the software, or you just fork and you go on your own path, and then since nobody else is using your path, then your blockchain is now worthless. Not that the data is worthless, though, because if you ever want to hop back on, you can at any time. Everybody has a copy of the same data. So you don't have to worry about that. Like, that's not like something you have to be too terribly concerned with. So those are the three major sections and the parts that kind of go into each section that a blockchain requires in order to operate. So let's talk a little bit about the consensus protocols. I've already briefly gone over proof of work, which is basically everyone works really hard to find something that solves. They solve for X. And when X produces a number that has a certain property, such as a hash that has 6 zeros in front of it, then they go, aha, I'm publishing my results to the world. And everybody goes, yep, he solved it. And then when they do that, they get a consensus going around, and then that person gets awarded, let's say, Bitcoin or Ethereum or whatever cryptocurrency is using the proof of work algorithm. So it's got some problems. So the big problem with proof of work that I think is that it's wasteful. And we talked about that when I said that it's using enough electricity to power a small country, and that's only growing. That's wasteful. That's just bad environmentalism. What's up?
I had a stupid idea. What if you just took problems that you actually need to solve and make that the blockchain that you choose?
Make that the problems you actually need to solve. Yeah, so we could talk about that afterwards. There's a lot of different types of blockchains out there, and trust me, they've kind of explored the options on that, and I could go over some of that with you. But so what he's basically saying is, can we use the blockchain to solve a known problem that you want, and then have people produce coins? But the coins have to have value themselves, and the only way they're going to have value themselves is if everybody wants to use the coin to actually produce to get value out of the coin. So other people want to exchange this coin as well. If there's no value in that coin, then there's really not a lot of value there. That said, you don't necessarily need coins for a blockchain to be successful. So I'll skip ahead to proof of authority. Proof of authority is a private blockchain consensus protocol. So let's say you're a business and you want to keep your business data private, but you still want all the advantages of a blockchain. Well, this is where proof of authority comes in. You could create a node on a series of nodes on the proof of authority, your internal network, that are authority nodes, and they're the only ones allowed to produce blocks. And They choose when they produce blocks, and there's no need for necessarily a currency. You can actually just have blocks added, and then you could create an internal ledger of data without actually having to have a currency at all. And so that's really interesting, especially for really sensitive data or government regulation exchange or that kind of thing. It's really useful for that. Though there's some question as to whether or not you even will need that in the future, but won't probably get into that today. So then there's proof of stake, which I skipped over a second ago, which is what Ethereum's kind of moving towards. In proof of stake, you take your coins. Let's say you have 1,000 coins. You put your coins on the network, and you basically say, I am vouching for these coins, and if I try and interfere with the network, I lose them. And so everybody's able to produce blocks at a much faster rate, much higher volume. It takes a lot easier math behind it, and you kind of do some sort of betting algorithm to get awarded coins. And it's a lot more, instead of needing these huge rigs to actually get rewarded for processing, you actually are able to do it with just your home computer. It makes things a lot better for the average user. And it doesn't even necessarily have to produce coins in that one either. You can have a fixed economy. So it's pretty interesting in that respect.
Does proof of stake work just as well, so to speak?
There is no completely operational proof of stake algorithm in the wild right now. But it is in research, and they are almost done with it at the Ethereum group. So there's a couple out there that do it in a very their own interesting kind of way, but yeah, this is there's no real proof of stake that's actually running in the wild, I think, with any degree of success at the moment. But it will probably next year. So there are some problems with blockchain still. There's privacy issues. There are instances where I don't think it makes sense for you to publish all your data. I mean, like you just don't want everything out there, and that's one of those issues is your passport. Like you need to be able to encrypt that and store it in a private way off chain, and then be able to retrieve that through the chain rather than have it actually in everybody's passport and everybody's data in the chain. You need to have privacy, and that works on a business level as well as a personal level. You don't want everybody to have everything. You do want to be able to grant them access to everything, but you don't want them to have everything, and that's where the blockchain comes in. Is you want to grant them the access to the privacy, but you want to be able to control your identity, which is a huge deal now because everybody's identity is pretty much everywhere thanks to ad networks and Facebooks and people tracking and selling your data and who you are and what you do and all this kind of stuff to marketing agencies and whatnot. You have no control over any of that. And one of the possible solutions is granting or incentivizing people to expose data about themselves, so that instead of just being sold for free, you actually may get some kickbacks on your data being sold. The other one is scalability. Right now, I think Ethereum does a couple million transactions a day. We need trillions of transactions a day. That's where we need to go. And we are going to get there. That is not something that's not going to happen. This is going to happen. We just aren't there yet. So you might be a couple years out. But trillions of transactions a day enable anybody to just operate on a blockchain and start using it like it's nothing. But there's also a problem with scalability of your data. So if you're storing a lot of transactions, trillions of transactions a day would make a huge ledger, a huge, and not everybody can have like terabytes and terabytes and petabytes of storage just to track this ledger. So we need a way of farming out the data and still validating it up the chain. So the root chain is actually a lot smaller, but as you specialize, it gets you can store the specialized chains, and they all communicate up the chain, and that's something we're working on right now. Vitalik Buterin and Joe Poon from Lightning Network, they published a paper called Plasma, which is really interesting in that it actually looks like it's going to work in that direction. So that might be like 3 more releases out for Ethereum, but it's on the roadmap at least. So we know that's going to happen. And once you get to trillions of transactions, that just changes everything. And then interchain communication. The Parity Group is actually working on something called Polkadot. And Polkadot is basically so that Bitcoin could talk to Ethereum, could talk to Litecoin, could talk to whatever. And so that you can have different blockchain types, root chain types, which actually are able to communicate with each other. The question of whether or not this is necessary is still up for grabs. Some people believe it is. I used to. Now I'm not 100%. I'm kind of halfway. I do still see some use cases, but with the Plasma paper, I kind of am wondering where they stand still. So interchain communication does seem really interesting. But really, if you have like a root chain, you're basically doing interchain communication anyway. If everybody just decides that there's one root chain, one internet, for instance, there's just one network we're all going to use, one DNS system, So, cool. So the future of blockchain. Obviously, the big one we touched on is you could do fiat currency replacement. So, for instance, the U.S. dollar. You could have national currencies. You could do multinational like the euro, or you could have one global currency that everybody in the world is kind of using. Whether or not that's preferable, it's up for debate, but it's definitely possible. The other one is securities. So you want to be able. There's actually a big problem right now where the SEC is kind of cracking down on these ICOs. One just got shut down on the 31st, which kind of shocked everybody. And there's something called a DAO, which got they basically retroactively said the DAO was problematic, in that a lot of these things that are on the blockchain as smart contracts come under security law, it seems, possibly. I'm not a lawyer, I can't really say for certain, but that's not a bad thing. It just means we can have transparency on the blockchain with these security trading, and it could be a regulator's, dream to actually get to actually have that kind of transparency and auditability instantly without actually having to go through a bunch of hoops in order to find out if these people trading are actually operating within the law. So there's that. Then there's fully automated corporations, which is pretty interesting in and of itself. Imagine that you have a business that just runs and you don't really have to do anything because all your contracts are in the blockchain. Anytime somebody engages with your business, they engage through these blockchain contracts and value is exchanged automatically, paperwork free. At the end of the day, you just do the taxes. Like that's one of the possibilities associated with this. So you no longer have to have a lot of lawyers. You get a programmer who's kind of got a law thing going on, and they write a smart contract which exchanges the value, and then when the value comes into your wallet, you go ahead and cash it out, and that's it. You don't have to do much except update your software or keep things going. It's pretty nice. Identity management we touched on as well. So for security purposes, it would be awesome if you could have a security database that everybody had access to and could unlock. So if somebody looks suspicious, they could actually ask you, hey man, you got the secure thing, but they're synced with the blockchain, and so they just check your badge and they go, yep, you're good. Privacy control, we touched on that as well. Credibility is a big one, so just knowing who somebody is. That's a lot of like the passport stuff, but also like verified accounts online. Also transferring your karma from one place to another. Wouldn't it be awesome if your Amazon seller account and your eBay seller account and your Amazon account and all that stuff, all those kind of synced with each other or could communicate with each other, and you could actually look at somebody's valid history. And voting systems. We have a big question about whether or not voting machines are up to snuff. You don't have to worry about that with this. You can actually just do it, and we can do that now. And election systems could be improved bigly. So, property rights. Another one is real estate titles could be stored in there, patents could be stored in there, vehicles, livestock. You could brand your livestock with something that actually gives them a serial, the code that actually says that you own this cow, and if somebody tries to snipe your cow, you go ahead and, that's my cow. There's a lot that can be done here. Real estate property is really interesting in third world countries where a dictator will come in and steal somebody's land that they've owned for 200 years, and then the dictator leaves power in 30 years, and they have trouble getting their property back because even though they've owned it for, their whole family has owned it for generations, they have no title proof because guess who burned all the titles? So this is really interesting. Banking is also very difficult for third world countries. So that's where the future of blockchain is going. And as you can see, that changes so many vectors of real life and every day that we are looking at the dawn of a new internet. I really believe that. We are looking at a new, like, Gopher era. Like, if you remember Gopher, anybody from, yeah, okay. So, nice. So we're looking at Gopher era, kind of like internet times. Like we're in a peak of a hype cycle right now, though. So it's really, it's going to go down, and people are going to, oh, that blockchain doesn't work, and then it's going to slowly, as the technology improves, things are going to get way better, and they're going to go, oh my God, that blockchain. And that happened in the early 90s. People were like, internet's not that big a deal. Nobody can even get on. Then suddenly everybody started to get on, and the networks improved, and speed improved, and people were able to actually get faster and faster and faster data lines, and then suddenly, whoosh, this is what the scalability problem will solve, and the privacy stuff. When we solve these problems, as they are being solved, there are solutions in the works. As they get implemented, These kind of things will change, and we will actually start to see blockchain integrate into every single part of our lives. So, since this is a music and gaming fest lab, I'm gonna kind of go back. I did talk about some of this already, so I'll just quickly go over it, so I can leave time for more Q&A. But in-game currency management is obviously a gaming use case. Auction houses, real money transfer, so player auctions could be a lot more reliable than they have been in the past, though I hear they've cleaned up. And then in-game item, asset serialization. You could have trading mechanisms built into the game using blockchain technology. You don't have to worry about the trades duping or anything like that. Asset valuation. You can actually use the actual serialization that you did here and say an item of this level of stats is probably worth this much, and you can actually track like how much individual stats are worth on an item. So if there's randomization on a particular item's roll, you can actually say that this item is probably worth about that much because it has like 10 extra ints than this other item, and so you can actually kind of do that kind of stat valuation in a dynamic sense, and you can write applications which actually code it independent of the game developer because everybody has a copy of the blockchain. Game key issuance. So there are real-world applications with physical goods. You could certify your goods on the blockchain. This is a legit system. This is a legit copy of this game. This is not a forgery. We can say that for certain, put it in the chain, and then never have to worry about whether or not somebody's trying to dupe us. And then game key issuance is also a great one. DLC downloads, all that kind of stuff. You can just issue the keys over the blockchain. Boom, done, unlocked. No big deal. Yeah. All right, so I've got a ton of resources here. I suggest you take a picture because it's a lot. But these resources are really great if you're trying to get into this stuff. Subreddit is where I started. I mean, I'm a Reddit junkie, so I started pretty much all in the subreddits. In fact, I first heard about Ethereum via the subreddit. And then this video is fantastic if you're into the tech part of it. Anders.com/blockchain. That guy has a 20-minute video which will blow your mind on how blockchain technology works. Sorry about that. You're welcome, I guess. I don't know. Isaac Arthur also has a really good video on blockchain, but he speaks more towards a futuristic sense, which is kind of what I like. It's a 30-minute video basically speaking of how blockchain does everything from today, voting systems, to tomorrow, interplanetary communication, which I think is just fascinating. So go to YouTube and search for Isaac Arthur-blockchain. I would have put the link up there, but I figured it was harder to type in than these other ones. A lot of podcasts. Big fan of the Bitcoin podcast. Epic Center TV and TechCom Politics is something that our managing partners run. There's some Slacks you could talk to. Everybody's really open in this community. They will help you. They want developers. They want developers. They want developers. They want people interacting with the blockchain. They want people using this stuff. They want the hype. They need the hype. They need people doing it, not just talking about it. So hop on board. Smart contracts for Ethereum. You got remix.ethereum.org, the Ethereum Wiki, and Solidity. And there's a lot of exchanges out there. Feel free to, if I left your favorite one out, I don't care. They all either do something, but none of them are backed by any sort of government authority. So caveat emptor. Utilities. There are some things you can actually do to look at the blockchain and see how things are going, and those are right there. So thank you very much, guys. If you want to follow me on Twitter, Medium, Instagram, there we are. Cool. So let me check. Hold on one second. 10 minutes. Wow, that's cutting it close. Okay, you guys got 10 minutes for QA. Go ahead. Sorry. Yes, privacy-based, security, kind of more oriented Bitcoin, but it's security-oriented, yeah. I think there's a lot of altcoins out there. They all serve a specific purpose. They all try and solve a very specific problem, and the way I look at it is that Monero is solving that problem in a very interesting way with mixing, and it's doing good work. But most of that work should probably be integrated into systems that are more adopted. And that's the way I feel about this. I look at a lot of these altcoins as being really great. If they wind up becoming mainstream, good on them. But for the most part, what happens is a coin like, for instance, Zcash implemented the ZK snarks algorithm for privacy using partial homomorphic encryption, which everybody's like, oh, wow, that's super cool. Like, So the Ethereum guys are going to integrate their algorithm into the Ethereum network. Why did we need Zcash? That's the kind of way I look at it. Maybe I just don't understand the economy enough, so I'm not giving anybody trading advice, but my opinion on it is that if it's not in wild adoption, don't do it. That's my personal philosophy. And wild adoption to me means that you are seeing huge transaction volumes, and I'm not talking about Ripple. I'm talking about like Ethereum and Bitcoin.
I'm just adding on to his, another district OX.
Again, I don't, wait, District O is another cryptocurrency?
Oh, it's like an Ethereum blockchain technology.
A token. Oh, so here, let's talk about tokens for a second. Tokens are great, and I think they serve a long-term purpose. I think there's a very few of them that actually have teeth. I'm not going to speak to any of them other than Golem because I am so confident that Golem has teeth that I'm not going to feel like I'm going to upset anybody in the room if I'm wrong because it's so close, it's so good. Like they're actually doing stuff. You're actually able to render farm on the block using the blockchain. So like Golems are pretty cool, but these tokens, read the white paper yourself, judge for yourself, but realize there are now currently probably almost 1,000 or some odd tokens just out there being published every day, and like they're you know, nothing happens. So you know, I'm still results driven at this point. I'm not seeing a lot of results, and so I'm not down on tokens as a concept, and I don't think you guys should be either. But I'm saying the timing is be very careful and don't get too heavily like amped about a particular token because none of them are producing results yet. And when they do, then you can be amped about it. That's my opinion. Go ahead.
Where do you come down on the technical decisions that cause the Bitcoin Cash split off?
I think that Bitcoin Cash split off was bound to happen with any hard fork. There's almost always a split off. I don't follow Bitcoin as closely anymore, so you're going to have to forgive me on that. But I do know that I follow the SegWit stuff a little bit, and SegWit needs to happen. They need to solve a lot of problems with Bitcoin, meaning that you know, their transaction times take too long, or you know, the volume that they have, their block size is too small. They don't actually seem to be able to handle the volume of demands that they have. And if you can't do that, then why are you even mining coins to begin with? So it frustrates me to no end when I see a developer community that can't form consensus because they don't feel like upgrading their systems. And it's just like, that's one of the problems with some of these blockchains, that since it's consensus-based, in order to do an upgrade, everybody has to agree to the upgrade. Ethereum has something worked into it called, I think it's called an ice age, where eventually it just becomes too costly to continue running on the same chain, so it does what's known as a hard fork. Like people just decide, okay, this is a good time to hard fork. It's just going to be ridiculously expensive to keep running on this chain. So it just hard forks onto a chain which doesn't have that problem. And so that's how Vitalik kind of worked in a self-upgrading mechanism without actually having a self-upgrading mechanism. So there's been some proposals like Tezos, which will broadcast changes to the blockchain to everybody, and then they all just take it. That removes some of the consensus removes some of the consensus values. So I don't know. We'll see how that works out. Updating the blockchain is a big deal. Anything revolving around Bitcoin Cash and anything like that, that's around the SegWit. That's all surrounding that same problem, which is how do we get everybody to agree what version of the blockchain they're going to run? Yeah, what's up?
Do you think Bitcoin will hit $500,000 in 3 years, or if it can't be used Bitcoin?
I would like to see both. I'm fine with either. Like I don't care. I don't make bets like that. I actually thought that Bitcoin wouldn't get as high as it is now. I feel like the fear of missing out is really hitting the currency markets more than I thought it would. But you know, I don't trade. I got out of that. I mean, I bought Ethereum at $2 and I sold at $350. So I am done with that. Like I've learned my lesson. Plus, I margin trade, and I would have been a lot better off if I didn't. So I got enough to make me square with a bunch of stuff, and then I was like, I'm done. So currencies are a wild market full of you know, FUD and FOMO, and I don't know what else to say other than that. If it gets to $500,000 of Bitcoin, awesome, I guess. I don't have any, so yeah, I'm an Ethereum guy now. But yeah, no, McAfee, he's hilarious. Anyway, anybody else?
Actually, I had something. You mentioned earlier about how you can put applications on there. Have you ever heard anything about potential like virus type applications being put into it?
So the EVM is a sandbox environment. You're not going to get outside the EVM, which is where but there have been smart contracts which were viruses within the blockchain. So, but they weren't necessarily viruses. They were either just poorly coded or something. Like the DAO is a big one. Yeah. So the DAO was a token that was put out, and basically it was it was basically it's a what was it? I want to say hedge fund, whatever. It basically allowed people to invest in an organization and decide where the money would go to invest more of their money. So basically, it's like it's basically like a mutual fund, I guess. I don't know, where they're actually able to vote on where their particular coin, value would go, and what percentage would go to which company. Yeah, and so like it would go. It was a contract which did that, and then somebody drained all the money from it because they had a bug in their code. So, like, verifying that a smart contract is correct and does not have bugs is a tough problem. Anybody in the room want to solve it? Because it's just one of those things. We're going to have a solution, but we're going to have a way of vetting and verifying and checking all the edge cases on these things for sure. But right now, that's not there. So, viruses on your system? No. In the blockchain itself? Yes. Read. Yes, you can, but the problem is that the transactions are immutable. So short of a hard fork where everybody reverses it like they did with the DAO, then which is not going to probably happen again, then you don't have you're kind of stuck with whatever bad stuff happened. You have to get it right the first time. That's why we test. Testing frameworks in this stuff is really important. Truffle has a really good testing framework. There's lots of Truffle is a smart contract framework for developing smart contracts in Solidity on the Ethereum blockchain. These development tools do exist. You just got to test. And you got to think. You got to think like a hacker. I mean, this is true for every code that you do. The problem is that this is so interacting with things that are actual value. It's like we're all in fintech all of a sudden. You know what I mean? We're all dealing. But we don't have the processes to deal with it. So we're going to build those processes. Everything's very early now. Like I said, we're in the gopher stage of the internet, man. So like, it's just one of those things that, whatever. It's just one of those things that you don't. You're not going to get right until you get it right, and you just have to be a little forgiving, because we're still working on it. But 10 years from now, you'll remember when you heard this talk, guaranteed. Cool. How are we on time? Done? Cool. All right. Thanks, guys. Cool.